Okay, now we're going to be solving equations using the zero factor property. So let's go ahead and start out right with an equation. Actually, before I do that, I do want to say one thing. I meant to say this in the last video, but I forgot to. Because the video before that, which was at 6.6, it was the only video for 6.6. And the one thing I wanted to mention that was that there was a glitch in that video where, once again, it looked like I was writing on top of something I had written before. They changed the way this program works, and it has had an unintended consequence that brings out a bug in my screencast software. So I apologize for that. But since it was a pretty small thing, and that was a 30-minute video, I didn't want to recreate the whole video just for that one thing. So at any rate, let's go ahead and I'll try to prevent that from happening in the future. I already have remade a couple of videos just because of that. So let's go ahead and start with this example. So let's say we have x squared minus 6x plus 9 equals 0. So x squared plus 6x minus 6x, excuse me, plus 9 equals 0. So the thing that I want to do here is remember what the zero property says. If a times b equals 0, then either a is 0 or b is 0. This is not in the form that we need it to be to use that yet. To do that, we first need to factor it. So let's factor this out. If we do that, we'll have x. Oh, okay, sorry. Let me start this over. We look for a few things. Remember, based on 6.6 to know what to do to factor. Basically, this section 6.7 requires that you understand everything from the previous sections. And that's pretty important to understand. So first of all, are there any common factors? No, there's not. Because there's a 1 here, so there can't be any common factors, and there's no other, and this term doesn't have any x's, so there's no common factors. Next we think, is this the difference of two squares? No, it's not. Is it a perfect square? Well, let's check that. See, we have a square number here. So if we do have a perfect square, then our a will be x. It doesn't look much like an x, does it? And we have a square number here. So this is x squared, this is 3 squared. Now let's test to see if this middle number works. This may look familiar because we've done it before. Okay, so we have 2. We're now testing to see if it's a perfect square. We have the square of the first term and the square of the last term. 2 times the square of the first term, the square root of the first term, which is a, times the square root of the last term, which is 3. Well, it equals positive 6. But we have here is negative 6, which means we have to change this last term from a positive 3 to a negative 3. So that means that we can now go ahead and factor this out. It goes from 2 times x times negative 3 to make negative 6. So this equals negative 6x, which is equal to the middle term, which means that we have a perfect square. So let's go ahead, and I'm going to, before I erase this, I'm going to go ahead and type it out. So, I'm going to write this over here, and then I'm going to write the factored form over here, then type it out here. So that means that this x squared minus 6x plus 9, we can rewrite this as x minus 3, because this is the square root of the first term, x squared. This is the square root of the last term. Well, this is minus the square root of the last term. And then we could write that as squared. You can go back and watch. If that doesn't make sense, you should go back and watch the video from 6.5, I think it was. So, of course, this is equal to this, which is equal to 0. See, all I'm doing here is I'm rearranging this side of the equation to from x squared minus 6x plus 9 to x minus 3 quantity squared. And that's still equal to 0. Okay, so now let's go ahead and erase this so I can type this part out. Okay, so we have x minus 3 quantity squared equals 0. So now we have two things that when you multiply them together make 0. Because this, by definition, what this means is x minus 3 times x minus 3 equals 0. Remember, that's the definition of x minus 3 squared. So that means that either this is 0 or this is 0. It just so happens in this case that they happen to be the same thing anyway. So that means that in this particular case, unlike the example we had from the last video, we have exactly one solution. Because either x minus 3 is equal to 0, x minus 3 is equal to 0, or x minus 3 is equal to 0. Since those two things happen to be the same thing, we're going to be getting exactly one answer, because we'll have x equals 3 or x equals 3. And if you come across this situation, and you will definitely come across this situation, then you will not need to write out this second part. You could just write x minus 3 equals 0 and then x equals 3. So this is not wrong, it's just redundant, it's unnecessary, which is why I scratched it out. So then x minus 3 is going to be our answer. So I'm going to go ahead and write that down here. I'm going to erase this and put x minus 3 in its place. X equals 3, excuse me. X equals 3 in its place. Just because that thing that was written there before was also redundant, unnecessary. So x equals 3 is my solution. I can check that by doing by putting 3 in for x. So I'll have 3 quantity squared. We don't need to put parentheses around this, but it's good practice. Minus 6, 3, plus 9. And so this is going to have to equal 0. For x to be a root of this equation, that's something a term I haven't used yet. Whenever you're finding where this is equal to 0, where x is equal to 0, sorry, not where x is equal to 0, whenever you're finding what x's make this polynomial equal to 0, that's called finding the roots of the polynomial. You'll hear those terms more. So 3 squared is going to be 9. Minus 3 times 6 is going to be 18. Plus 9. 9 minus 18 will be negative 9. Plus 9. Negative 9 plus 9 equals 0. So that's again supposed to be a check mark. So then negative 9 plus 9 equals 0, so we know it works. So that means that this is going to be our final answer. Okay, that concludes the first example. Let's go on to the next example. Let's say we have x cubed minus 9x equals 0. So let's put a little bit more space there. So x cubed minus 9x equals 0. What's the first thing we do whenever we factor something out? We want to factor out the greatest common term. Well, it just so happens that x is common to both of these. So that means we'll have x times x squared minus 9 equals 0. All I did here was I factored out the x because there was an x common to both of these. Now what do we have here? Can we factor any further? Well, yeah, we can, because this is a difference of two squares. So we can change that to x times x plus 3 times x minus 3 equals 0. Whoops. Equals 0. X times x plus 3 times x minus 3 equals 0. So now we have 3 factors that would multiply together equal 0. So one of them has to be 0. So I'm going to do this over here. So we have x equals 0 because that's one factor. Now if this were like 5 or something, then you can't say 5 equals 0. So don't ever write that because 5 is not equal to 0. So then we can have x equals 0 or x plus 3 equals 0. Or x minus 3 equals 0. So this is already in the form that we need it to be, but for this one we need to go ahead and subtract x from both sides. Subtract 3 from both sides. Good, x equals negative 3. or x equals 3. So that means we will get as our solutions x equals 0, or x equals -3, or x equals 3. Okay, so now that we have that written down here, I'm going to go ahead and clear that off. So x equals 0, or x equals -3, or x equals 3. Let's go ahead and check those answers. So what if x equals 0? So we need to find out if the left side matches the right side, or if this will equal 0. So then that'll give us that 0 cubed minus 9 times 0. What does that equal? So then 0 cubed, that's just going to be 0 minus 0 equals 0. Okay, so that turns out to be exactly what we expect it to be. 0 minus 0 equals 0. So that means that for x equals 0, our solution's good. Now let's try x equals -3. So let's plug it in, see how it comes out. We have -3 cubed minus 9 times -3. So that equals -27, because 3 times 3 is 9, 9 times 3 is 27, plus, because we have -9 times -3 will give us plus 27, so that equals 0. So that's good. I didn't put a check mark here. So our first two solutions we've checked and they work out. So then next is x equals 3. So then we have 3 cubed minus 9 3. Well, that's going to equal 27. 3 cubed is 27. Minus 9 times 3 is 27. Equals 0. So our solutions work. Forgot to put a colon there. Okay, so all three of our solutions work, so we're pretty sure we did it right. So these are going to be our solutions. Alright, let's do one more example. I'm just kind of curious. I mentioned before about using the terminology root. I'm not sure if it's often done. Yeah, okay, that term is often used, I think, for this type of thing. Okay, anyway, that's a side note. So let's clear that off and go to another example. So we have, this is a big one. This is a hard one. X plus 2 times x minus 3 plus 4 equals negative 2x times 7x plus 1. Okay, at first glance, this doesn't even look recognizable as the type of problem that we're doing, because we see this and we don't really recognize that it's not in the form that we expect it to be in. It's not in what we call the standard form. When you're looking for the roots of an equation, one thing you want to do is put it in the standard form. Not roots of an equation, roots of a polynomial. What you want to do is put it in the standard form. So, remember, we wanted to get this in the form ax squared plus bx plus c equals 0. This is the standard form for a polynomial, I guess, for an equation, I guess you might say. So let's go ahead and what we need to do is we need to multiply all this stuff out and then combine everything on one side of the equation, and then we'll have it in standard form. So let's go ahead and do that, and you'll see what I'm talking about. So if we have this first one, you have x plus 2 times x minus 3. Well, this x times x will give us x squared, and then x times negative 3 will give us negative 3x. This 2 times x will give us plus 2x. This 2 times negative 3 will give us minus 6. So all I did here was I multiplied out this stuff here, and so I'm done with that foiling, so I'm going to get rid of it. And then we still have this plus 4. So plus 4 is still there. Then on the right side here, we still have the right side to deal with. So we have negative 2x times 7x. That's going to give us negative 14x squared. And negative 2x times 1 will give us negative 2x. Okay, so now we have everything multiplied out. Let's move all of this stuff over here. Actually, first let's combine it, because we have two different places where we have like terms on the left side alone. Let's go ahead and combine that. We have negative 3x plus 2x, and we have negative 6x plus 4. Not 6x, sorry, it's just 6. Okay, so let's go ahead and combine those like terms. So we have the x squared still. Negative 3x plus 2x is going to give us minus x. Negative 6 plus 4 will give us minus 2. Then on this right side over here, we don't have anything to combine, so we'll have negative 14x squared minus 2x. Now let's take everything on the right side and move it over to the left side. So I want to add 14x squared to both sides, so plus 14x squared, and we found the like term over here, 14 14x squared. Barely have enough room for a tiny plus there. That's going to give us 15x squared. And this 2x, we want to add 2x to both sides. Plus 2x is really small. That'll give us plus x. Then we'll still have the minus 2 equals 0. So I'm going to go ahead and I'm going to type this out and then clear off all this stuff. So we have 15x squared plus x minus 2 equals 0. Okay, so now let's clear that off. Wait a minute, that is not correct. There we go, so 15x squared plus x minus 2 equals 0. Okay, now I'll clear off all the writing. Okay, so 15x squared plus x minus 2 equals 0. Now we're getting somewhere. Now we have it in a form where we're now at the place where we can factor. So how do we factor this? Well, is there a term that's common to all of these? No, there's not. Is there a is this a difference of two squares? No, it's not. Is this a perfect square? Well, neither 15 nor 2 are square numbers, so no. So that means we're left with one thing. We've got to guess and check. Now, we could do factor by grouping if we wanted to. That would work just fine, but it's a little bit more straightforward, a little bit easier to try guess and check. So, what two numbers multiply to make 15? Well, let's try 3x and 5x. And we have a negative here on the right side, so there's going to be 1 plus and 1 minus. So, what two numbers multiply to make 2? Well, 2 and minus 1. So, let's go ahead and multiply this out. Check it, see if it works. 15x squared, we knew that was going to work. And then 3x times negative 1, so negative 3, plus 10x minus 2. That doesn't work because negative 3x plus 10, that's going to give us 7x, and we want to get 1x. So that particular solution does not work. Let's try another combination of those numbers. 3x, let's go with plus 1, 5x minus 2. So that'll give us, of course, 15x squared for the first term. 3x times negative 2 will give us a minus 6x. 1 plus 5x times 5x will give us plus 5x. And then 1 times negative 2 will give us negative 2. This is going to be the exact opposite of what we want, because we're going to get minus x. So that means we just switch the sign. So let's redo this, but switching the signs, and I'm going to do it over here. So we have 3x minus 1, 5x minus 2. So then we'll have 15x squared minus 6x. Whoops, I forgot to put the plus there. Plus 6x. I meant to switch those signs. Plus 6x minus 5x minus 2. Now we have 15x squared plus x minus 2. So that means this is the correct factorization. And I kind of wish now I hadn't put it here, because now I'm going to have to type it out on top of this. But I'll go ahead and write it out and then clear it off. So we have 3x minus 1 times 5x plus 2 equals 0. So 3x minus 1 times 5x plus 2 equals 0. Now I'll clear all that off. So now we have two things that, when multiplied together, equal 0. So that means that either 3x minus 1 equals 0, 3x minus 1 equals 0, or 5x plus 2 equals 0. Either 3x minus 1 equals 0 or 5x plus 2 equals 0. So now we can solve these individually. So if 3x minus 1 equals 0, well then 3x equals 1 and x equals 1/3. And so that's one solution. X equals 1/3. Or, and then we'll have, put a divider here, 5, how does it look like 5? 5x plus 2 equals 0. So 5x equals negative 2, or x equals negative 2 over 5. So their next solution is x equals negative 2 over 5. Okay, so now that that's done, I'll go ahead and clear that off. Now, I'm not going to, just because for the sake of time, I'm not going to check these answers. You'll just have to, you could do one of two things. You could either trust me, or you can plug them in for yourself. You plug 1/3 into the left side, and then 1/3 into the right side, and then see if they equal the same thing. If they don't, then there's something wrong. And then you do the same thing with negative 2/5. I don't, like I said, I just don't want to take the time to do that right now. So for now, that is the end of section 6 of chapter 6 of the entire chapter 6. All right, see you in chapter 7.